All right, hello class. This is the first time I'm doing this, so bear with me on this. When I was on the way home, I had an epiphany that I received a lot of questions today about dropping and swapping, and I was very confused because it seems like a very simple process. So I decided that I would post a little video about what dropping and swapping is and why we use it in chemistry so that you could have it for your reference. So I'll try to do that in 5 minutes or less. So when you're dropping and swapping, you're doing it with an ionic compound. So an ionic compound is one that's made up of a positive ion, let's call it X, and a negative ion, let's call it Y. The positive ion and the negative ion have a certain amount of charge associated with them. The idea of an ionic compound is that the amount of the positive and negative charge are balanced so that your molecule overall will have a net zero charge. We know this because molecules don't tend to have electrical charges. We don't walk around and have molecules zapping us all day with electrical charge. So most of the molecules in the world must be electrically neutral. And that is in fact the case with ionic compounds. So what I mean by drop and swap is we're taking the amount of the positive charge. So let's say these are +1 and -1. We're taking the amount of the positive charge, which is 1, and we're writing it as the subscript for the negative ion. And then we're taking the amount of the negative charge, which is 1, and we're writing it as the subscript for the positive ion, which means that this chemical formula should be X1 Y1. Since we don't write 1 subscripts, that means that our chemical formula would be XY. Now, if we have a different amount of positive or negative charge, let's say this ion was a +2 ion, and we were combining it with a -1 ion. Well, intuitively, we know that it would take 2 -1s to balance out a +2 charge. So, if we drop and swap by taking this 2 and writing it as the subscript for Y, and taking this -1 and taking this 1 and writing it as a subscript for X, that will prove to be true. So dropping and swapping would predict the chemical formula X1 Y2. This 2 gets written as the subscript for Y. This 1 gets written as the subscript for X. Since we don't write 1 subscripts, that gives us the chemical formula XY2. Finally, let's say we have something with a +2 charge and something with a -3 charge. Dropping and swapping would predict that this 2 would be written as a subscript for Y, this 3 would be written as a subscript for X, and it would predict the chemical formula X3Y2. That is how you drop and swap. Now, let's apply it to a system. I'm teaching this to you guys because in going from chemical name to chemical formula, you often have things like this. Let's say that we have aluminum oxide. And this will be the case for any ionic compound. All we need to do in order to identify what the chemical formula is 1, identify the ions, the positive and negative, 2, drop and swap, and 3, reduce if necessary. If you can follow those 3 steps, you will be able to write the chemical formula for any compound name that I give you. For example, this one. We can look at our periodic table to determine that the aluminum ion has a 3+ charge, and that the oxygen ion, or the oxide ion, has a 2- charge. Therefore, we would write this 3 as a subscript for oxygen, and this 2 as a subscript for aluminum. That gives us Al2O3, which is the formula for aluminum oxide. Now, where people get confused, it seems like, is when we have a polyatomic ion, let's say like sulfate. In reality, it's no different than doing this up here. except instead of using a single element for Y, we're using a group of elements. So instead of using, for example, nitrogen here, which would have a 3- charge, we're using phosphate, or PO4, which together has a 3- charge. So let's take a look at an example. Let's say we're doing aluminum sulfate instead. So from our periodic table, we know that aluminum has a 3+ charge. We're going to identify that ion. From memory, or from the Nick the Camel sentence, we know that sulfate has a 2- charge. The formula is SO4 2-. So we would predict that we need to write this 3 as a subscript for sulfate. We need to indicate that there are 3 sulfates. And we would write this 2 as a subscript for aluminum. So the way that would work is we would write the chemical formula Al2, and then we need to somehow indicate that there are 3 sulfates. So the way that we do that is we set the sulfate off with parentheses to indicate that this subscript 3, which we need to write, is the number of sulfates that we have. It's the exact same as doing this process, except we need to write this 3 as the subscript for this polyatomic ion, sulfate, because this polyatomic ion has a charge of -2. That 3 -2 charged sulfates balance out 2 +3 charged aluminums to make for a net charge of 0. That's the entire point. So if you can do this, process for Wednesday, you should get every single problem on the name to formula part of your test right. Hope that helps. Tell me if it doesn't. Thanks, bye.